Now we continue. So we now have the graphic about the current and voltage when the circuit just contains resistor, and voltage and the current is at the same phase. In other words, voltage and current have the same phase. Now, according to the law, if we have P equals Vm sin omega t, so the current also have the sinusoidal form. So in instantaneous current is current maximum sin omega t. And it easily we can write that is this. So we have this one. This is the expression mathematical of the abstraction of the voltage. Yeah. And if we have the circuit like this one, it means V here is the same as V resistor here. So if the V is in the function of T, V R also have the form, the function of T. Okay. So we get here delta V equals delta VR equals V maximum sin omega t. Of course, this amplitude is the maximum voltage. Maximum voltage. Now we can express in current expression that the current through the resistor is IR equals VR over R. Okay. So VR have the sinusoidal form like this one, and then divided by R. So according to the law of Ohm, we get here delta V max over R is the maximum current. Okay. So the maximum current is V maximum over R. And we can also express the instantaneous resistor voltage as I maximum times R sin omega t, because it also V maximum. Okay, V maximum is I times R. Yeah, I think it's very clear. Now we move to the next topic. Now, how if the circuit contain the inductor? You can see here, there is an inductor and the generator, alternating current generator. Okay, to understand what is the current, instantaneous current, or the current that through the inductor as the function of t, we can start from the law that the resultant voltage difference equals 0. Sigma tegangan jepit pada rangkaian tertutup itu sama dengan 0. We have two components here. V, this V or delta V, and this one is the voltage difference comes from the inductor. So this one is VL. So from this expression, we have V plus VL equals 0. And you can learn from this equation. V equals delta V because it's just a symbol. And then VL here is the inductance that we have learned from the previous meeting. The inductance is the electromotive force caused by the inductance minus L d I dt. Now we can process the next expression. It's very simple, and we have this one. I think I have explained also in the video. You can learn from the previous video. But I think by reading this PDF, you will understand. But you have to write again by yourself. Yeah. So we have we rearrange the expression, become this one, and we rearrange again, so we have the form of di. Is the form di, and the current we can obtain if we integrate both side, the left side and the right side. This is the constant variable, so we can put out from the integration. And we integrate both sides, we have this one. Now we have learned from our previous calculation in resistor. So we can also change this expression into minus cos omega t equals delta V max or V just V max divided by omega L sin omega t minus P over 2. Okay. Now we have this expression. We can say this this term is the the current of inductor maximum. Okay. Delta V max equals omega L. And we have to take the analogy of this from the law of Ohm, from this expression V over R. So this one must be has the unit of Ohm. Okay. So we have to take the additional variable here to include omega L here, to variable omega and L into the new variable. And we can say this variable is XL. XL equals omega L. And this one has the unit of Ohm. Omega or, and we call this variable as the inductor reactance, inductancy, inductance, reactancy, inductancy, ya. Reaktansi, inductansi kalau di bahasa Indonesia ya, si, or inductance, reactance. Any question? Is the mathematical expression of EL as the function of T. So now we have this XL, we can express as inductive reactance. Reaktansi, induktansi, kalau bahasa Indonesia. Indonesia ini adalah inductive reactance. Nah. Any questions? And according to the previous calculation, we know that EL also have the expression like this one. Okay. From the base voltage is VL equals V, the function of T equals V maximum and sin omega T. And the expression of current has the additional phase here. This is the phase difference. Ini adalah beda fase. The phase difference of the current is minus P over 2 compared to the voltage. Now we can say that the phase of the current is minus P over 2. Or you can say here, you can read here, the current lags behind the voltage. Ya. Jadi fase dari arus itu ketinggalan sebesar 90 derajat atau Pi. Di fase ketinggalan ini dinyatakan dalam ini lag, ya. Ada jeda waktu. Nah itu jeda waktu itu disebut sebagai jeda fasenya. You can see in this graphic, the voltage start from here, start from 0 and then to the maximum point. But the current still to the lowest point, and then the voltage reach the maximum point here, but there is a lag for the current, and the difference time is here is P over 2. This distance in the time, we can say that this one is P over 2. So we can say that the current lags behind the voltage. Arus ketinggalan terhadap tegangan. Arus ketinggalan terhadap tegangan. Nah, itu ketinggalan sebesar Pi per 2. And actually we can also learn from the FET simulation, and I have record the simulation from this video. So please watch the video just for a moment. And before I start the video, I think if you want to try to make the simulation by yourself, you have to I will import the simulation, the file of the simulation. Number one is the compiler of Java programming. Is the Java compiler. And then the second one is the simulation itself. The circuit, electric circuit simulation. This is the circuit construction kit. So if you want to try later, you just download these two files, and firstly you have to install the Java compiler. After you completely install, you also double click in this file that you have downloaded before. Okay, and you will have this simulation. I want to maximize the screen. And please watching this video that moment to make you understand about the simulation. Yeah. Seolah-olah ya ada osiloskopnya kalau pakai FET ya. Tadi kan apa tadi induktor. Nah, kemudian tegangan AC, kemudian saya pasang saklar ini kabel. Kita hubungkan sini ya. Jadi dalam konduktor itu ada banyak partikel pembawa muatan, jadi elektron yang bergerak. Bergeraknya itu enggak seperti ini karena tegangannya kan AC ya. Jadi kanan kiri atau atas bawah. Tapi kecepatannya itu rendah ya. Maka kemarin yang kalau ada yang bagaimana kalau kita menggerakkan konduktor, ada pertanyaan ya, digerakkan dengan kecepatan tak terhingga. Tapi tetap yang ini itu ya nggak bisa cepat, karena kan saling berdekatan ya, bukan satu sama lain. Jadi geraknya ya, yang dinamakan kecepatan drift itu ya rendah, ya tetap kecepatan driftnya itu rendah. Kalau kita lihat sekarang, kita akan melihat fase tegangan sama fase arus. Nah, ini tegangan yang bawah, saya taruh bawah ya. Kan kita akan melihat kalau tegangan kan untuk melihat tegangan kan dipasang paralel ya terhadap induktor ini. Saya dekatkan sini. Nah, kalau mengukur arus ini kan bisa kita lihat di sini aja. Kalau dalam prakteknya kita putus kabelnya, kita pasang secara seri ya. Dalam prakteknya untuk tegangan. Nah, ini kita lihat ini ya. Ini kalau saklar ditutup, bagaimana bentuk grafiknya? Ini grafik V yang atas I. Ini kita lihat sekarang. Kita tutup. Nah, itu kita ulangi lagi ya. Mungkin ini saya sesuaikan dulu supaya kelihatan fasenya ya. Ya, nah ini saya riset lagi ya. Saya buka, ini saya riset dynamics. Risetnya ini. Ya. Nah, ini kan nol. Ini masih belum, ini saya tutup. Fasenya bagaimana nanti? Nah, itu kita lihat di sini. V-nya itu mendahului. Ini kan sampai puncak di sini ya. Puncaknya masih di sebelah kiri. Nah, coba ini saya pause nanti ya, di situ. Ketika ini saya pause, di sini saya pause, nanti akan kelihatan datanya. Ini saya pause. Okay, everyone, you can see here the voltage reach the maximum point after the current. So there is a lag between current and voltage. And we can say that the current has a lag from the voltage. Ya. Jadi fase arus ketinggalan terhadap tegangan. Ya. And the phase difference here is P over 2. Similarly, you can also make the simulation for the capacitor yourself. Okay. Now I will continue to the next topic. Any question, everyone? I will...
Not yet, sir.
Not yet, sir.
Okay, thank you. Now, how if the circuit contain the capacitor? Okay. Contrary from the previous topics, the inductor, apparently the phase of the current is has the phase, the different phase P over 2, P per 2 here. Now the lag phase is the voltage. Okay. Now you can see in the circuit, capacitor circuit, and please read mathematical derivation to obtain this expression. Okay, is learn by yourself. This one, I think it's very easy. So we have the current through the capacitor is this one. From this expression, we know that the phase of the current is plus P over 2. Now the phase of the current is greater than the voltage phase. Okay. Jadi fasenya ini lebih dulu, lebih besar daripada fase tegangan. Jadi fase arus mendahului Pi per 2 terhadap tegangan. And this term is the maximum current. According to the analogy with the Ohm's law, so this one has the unit of. And also we have to force this expression to move to the bottom here. So the expression will be 1 per omega c. So this term is the capacitive reactance. Ya. Semoga benar ini. Capacitive, kita lihat apa bahasa Inggrisnya ya. Capacitive reactance. Or in bahasa Indonesia reaktansi kapasitansi. And the symbol of this one is XC. And the unit, of course, ohm. Okay, now we should see the graphical expression. Now the lag one is the voltage. The voltage lags behind the current. Jadi fase tegangan tertinggal 90 derajat terhadap arus. Kalau tegangannya di sini, maka arusnya sudah di sana. Now you can see in graphical like this one. This is the graphic of V, the voltage, and then this one is the current. So the current has the maximum point at T0, but the voltage just still in the 0 point. So the voltage here, the voltage lags behind the current. Fase arus ketinggalan sebesar Pi/2. Jaraknya kan Pi/2. Ketinggalan Pi/2. Now we have capacitive reactance is Xc equals 1/omega C. I think you still remember that omega is 2πf. This is the frequency in hertz. This 2πf. This one is P. 2πf. I think if you can draw in simulation, you will be able to answer this question. I think if you have the curiosity, you want to understand by using the PET simulation. Is the case that there is a light bulb, the bola lampu, and then attached to the inductor and attached parallelly with the capacitor. Now the question is when the voltage is in alternating current and constant, or the frequency of the constant one is the frequency. The frequency of the alternating current source is constant here. So F is constant. And then the voltage amplitude, Vm also constant. Now the light bulb will glow the brightest at. Jadi kapan bola lampu ini menyala paling terang? In high frequencies, low frequencies, or the brightness will be the same at all frequency. Jadi yang konstan itu yang ini, Vn, yang bisa diatur itu yang ini. It can be adjustable. Bisa diatur. Nah, bola lampu akan menyala jika frekuensinya ini bagaimana? Tinggi atau rendah, atau tidak terpengaruh. Coba dibuat simulasinya ya untuk nyoba-nyoba kalau ingin mengetahui. Ini saya lanjutkan Rlc. Jadi now we move to the Rlc circuit. Rlc circuit contain of this one, resistor, inductor, and capacitor, and attached in the loop. Jadi digabung dalam satu rangkaian tertutup. And the source is alternating current. Now, if we consider the delta V is Vmax sin omega t, so the current must be E maximum sin omega t minus V. Okay. Now we will learn about the V. We have here R, the resistor, and then L we express in the reactance. This XL, and then this one is XC. So if we draw the Phasor diagram, we will have this one. The horizontal axis is the real axis, and then the y-axis is the imaginary. Okay. I'm sorry, I will enlarge the graphic. The real part and the imaginary part. Okay. And the resistor is in the imaginary part. This is the resistor. Resistor all are through V and I, but we will talk later. And then XL and XC is in the imaginary part. XL is in the positive axis, and then XC is in the minus axis. Now, the V is the angle of the resultant. So, if we talk about the reactance in all the components, it means all the components will expressed by the reactance, but the total reactance we call as the impedance. Impedance is the impedance. The impedance can be calculated. So we have to calculate XL minus XC. So we, for example, here we have here this one is the XL minus XC. This is C. So the resultant of XL minus XC and R is here. We have this one is the impedance. Can see. Of course, the impedance can be expressed as the square root of R squared plus XL minus XC squared. So P here is the angle of the impedance. Okay. So we can calculate the phi as tangent phi equals XL minus XC over R. Now you can find phi is the hyperton of XL minus XC over R. The inverse tangent of XL minus XC over R. Any question, everyone? No? Okay, we continue. Now, after we know that the expression of I is I max sin omega t minus phi. But before we, sorry. Before we move to the next topic, we should learn about the effective voltage and current, effective current. Now we should talk about this one. The effective value of current and voltage. Generally, if we have this voltage, for example, this voltage, and the amplitude is Vmax. But if we utilize the electricity, we just get this area, okay, and this part we express as the effective voltage. And if we measure the voltage by using voltmeter, the value indicated by the voltmeter is the effective value. Jadi yang terukur pada voltmeter atau yang kita pakai itu adalah ini, tegangan ini, ya. Effective voltage, or in theory book maybe the RMS, it means square voltage. And this effective value can be expressed as V maximum of square root of this one. And also the effective current is I maximum of square root of 2. And maybe in the test, I think it's very clear the statement of effective or maximum value, and you just be careful to differ the value in the test. It is effective or maximum. Now, next, back to the survey book. Now you see here is the comparison of VR, VL, and VC in series circuit. Okay, VR, the angle, the phase is the same as the total the phase of the generator. The phase of resistor is the same as the phase of the generator. You have to remember that the generator have V equals Vm sin omega t. So the voltage difference that has the same phase just in resistor sin omega t, and this one also sin omega t. But the voltage difference, ya, tegangan jepit dari induktor is Imax XL. I think it's very clear why Imax XL, because we talk about the voltage. So if we talk about the voltage, we have to express this part as the VLX. Tegangan induktor maksimum. And VLX we can say as Imax time XL. So you have to understand we use Imax all in the voltage difference because the current flow through the three component is the same. Is also t I as the function of t, and the current is the same. Like the expression before, I of the function of t, the function of t is I max sin omega t minus v. Okay. Now you have to be careful. This one is the phase is plus p per 2. Okay. Because VL is leading to P over 2. Ya. Jadi fase tegangan dari induktor itu pimpin, leading itu, mendahului. Ya. Nah, ini kan sudah ini mendahului, muncul duluan ini yang puncaknya, yang lain kan masih di sini, selisih Pi per 2. Apalagi yang VC, selisih Pi, ya, selisih yang Pi ini. VC, P antara VL dan VC. Ini kan selisihnya adalah P. Plus P per 2 dengan minus P per 2 kan selisihnya adalah P. So, please consider this expression. It's very important. Especially about the phase difference beta phasor. Any question, everyone? No?
No, sir.
Okay. And now we move to the next topic. And I will give the example for chapter 9. Oh, I'm sorry, I have attached the present code in your classroom. The present code is already listed in the classroom. Chapter 9, example of chapter 9. And I also put this example in your classroom. This is the example of chapter 6 problem. For example, this one, I think it's very clear. Maybe we can. I will move in this expression in this problem. You can learn by yourself for 25 and 29. Oh, I'm sorry. I will move to 27 this time. Sebentar ya. Okay, now number 27. There is a RLC circuit composed of resistor 20 ohm, and then the inductor 35 millihenry, and the capacitor is 50 microfarad. And attached to the alternating voltage, and the voltage is V maximum sin omega t, and has effective voltage. Nah, ini yang berarti tegangan efektif. Effective voltage 100 volt, and the angle frequency is 1000 radius per second. And calculate reactance of the inductor and capacitor. This one is to calculate XL and XC. XL is omega L and XC is 1 over omega C. XC is 20 and this one is 35. Okay. Now the impedance of the circuit, C of course is the square root of R square plus XL minus XC square. Okay. I think we have talked before about this. Okay. And then the effective current. It's very simple. That effective current is V effective voltage divided by C. So if we have the RLC, so to calculate, to convert the effective to maximum current, there is a relation. The relation can be obtained from C, the impedance. Okay. So EF is V effective divided by C. And we can also express I effective, the I maximum of the square root of 2. Okay. And we can apply this one. And the relation between maximum current and the maximum voltage also of Vm of impedance. Now the next question. And draw the Phasor diagram of the circuit. This is the Phasor diagram. We can draw the real part as R or V effective R or V maximum R. You can choose by yourself by using R or the effective value of R or So E effective, ya, or V maximum. And this solution use the VR effective. So in the imaginary part is VL and the -1 is VC effective. So we calculate for the first time is VL minus VC effective. And then we can draw the resultant. This one is the resultant, so this one the P effective. Okay. This one the P effective. The resultant. Or we can express in the reactance. This one is R and then XL, XC, and this one is XL minus XC. And then this one is the resultant. The resultant is the impedance. Okay. Equals R square plus XL minus XC square. Like this one. So you can choose what graphic you want to draw in impedance or in voltage. Okay. Now the power factor, ya, faktor daya. Sebelumnya ini sudut fase. Sudut fase kan bisa diperoleh dari sini. This one is V. So V is the arctangent of XL min XC, XL divided by R. So you have V is 37. Now about the power factor. Faktor daya. Faktor daya itu bisa dinyatakan dalam VI cos theta. Cos theta. The power factor is cos V, not cos theta. Cos V equals R per C. But you can also express cos V directly if you already have V here. So cos V also cos 37 because you have P before, yeah. 0.8. So the power in the circuit is V effective, I effective, and then cos V. So we can maximize the power into the circuit to adjust cos V to be 1. Jadi daya akan maksimum diserap pada rangkaian, ya tidak ada yang hilang dalam bentuk panas jika cos V sama dengan 1. How to adjust cos V equals 1? So cos V equals 1, it means V must be 0. V must be 0. From this expression, V can be 0 if only XL minus XC equals 0. Ya kan? Ini bisa dicapai. Ya, jadi daya maksimum itu bisa tercapai jika cos V sama dengan 1. V sama 1 dicapai jika V-nya 0, karena cos 0 kan 1. Ya, cos 0 1. Kemudian supaya bisa mencapai cos 01, XL min XC harus 0 berdasarkan ini, kesamaan ini. Ya. XL min XC must be 0 to reach the V equals 0. And if you can put R to 0 because it is prohibited. Ya. R-nya nggak boleh 0. R-nya 0 sudah nggak ada nilainya. Ya. Tak terhingga nggak tentu nanti nilainya. So the only one to make the cos V equals 1 is XL minus XC equals 0. Any question? Please read again in 2 minutes or 1 minute to understand. I will continue later. Yeah, any question, everyone? You try to solve the problem.
It's quite clear, sir.
I think it's clear,
Yes,
sir.
I think it's pretty clear, sir.
Okay. Now we have the special case. The special case when XL minus XC is 0. And you will have this equation because XL is omega L and XC is 1 over omega C. And by little derivation, you will have this one, omega resonance. So here's the special case. If XL equals XC is when we have the angle Yeah, the frequency we call as the resonance frequency. The resonance frequency. We have the square root of 1 over omega. Sorry, Lc is the omega frequency, and then the resonance frequency is the endo frequency. The resonance frequency is omega over 2p. From the expression omega is 2pf. So f is omega over 2p. It's the resonance. And next, it's very clear that effective voltage of Rlc can be calculated by this expression. So from this expression, we have I max, I as the function of t is I max sin omega t minus v. Then on next example, please read this one by yourself. Yeah. This wire to transmit electricity, this should transmit in high voltage, not in lower voltage. Because if we transfer the electricity high power and we use the lower voltage, I think from this equation we have much loss in the form of heat. Jadi daya hilang kan semakin banyak kalau kita menyalurkan dalam tegangan. So we have to transfer the electricity in high voltage to reduce or to minimize cost. Okay. Then in test number in chapter 5, chapter 6 is quiet PC in the test. Now, please, I will show the example of chapter 5. You can see in 14 June there's a problem solving. Di sini ada beberapa 5 ya. So I think the problem in final exam is like this problem. I think the complex one, for example, in number 4. Okay, and then I think it's very easy for number 4. And usually the test put in the final exam is quite difficult. Yeah. For example, this one. It's very it often put at final exam. There's a long wire, and then the long wire produce the magnetic field. Tapi medan magnet yang dihasilkan di sini kan nggak konstan, tergantung jarak dengan ini. Kemudian ada konduktor yang digerak-gerakkan ya. Biasanya kan tidak ada kawat ini dan medan magnetnya itu konstan. Jadi gampang, tinggal GGL yang dihasilkan adalah BLV. Tapi kalau medan magnetnya tidak konstan, konstan tapi tidak seragam ya, tidak seragam ini karena B di sini lebih besar daripada B yang di sini karena makin jauh semakin lemah. Ini kan tidak seragam. Nah, ini cara menghitungnya seperti ini. Please make a rewriting by yourself to make you understand how to make the small element and then integrate to the all area. Silakan dipelajari sendiri ya, kemungkinan besar ini sering keluar ini ya. Coba dipelajari yang ini ya. Soal seperti ini yang sering keluar. Dan ini mungkin yang keliru ya, yang ditanyakan GGL. GGL terjadi ketika ada perubahan B, ini kan B ya. Kalau B-nya konstan tidak ada GGL. Jadi GGL-nya terjadi di sini. Ini bisa dihitung sendiri. GGL-nya kan sama dengan perubahan flux terhadap waktu. Ini N, A yang berubah kan berarti B-nya. Karena petanya kan 0. Searah antara B dan luas penampang searah dari soalnya PDT. Nah, di PDT ini bisa diganti B, ini waktu 30, kurangi B ketika 20, when 20 second, and then divided by 30 millisecond minus 20 millisecond. But you have to convert millisecond to second ya. Nah, ini bisa dihitung sendiri. Ini saya tunjukkan yang soal sering keluar ya, seperti tapi dan juga ini mana ya? Ini penurunan torida biasanya nggak keluar. Nah, seperti ini soal ini. Nah, seperti ini sering keluar juga ya. Jadi di luar itu ada solenoid panjang, there's a long solenoid here, and then in the middle of the axis there's a small coil. There is a small coil inside the long solenoid. kasusnya seperti itu. Yang keluar. Nah, ini juga ini pelajari. Nah, jangan bosan-bosan menulis ulang ya. Jadi di sini walaupun ada solusinya, tapi Anda itu harus menulis ulang. Kalau enggak gitu nanti enggak bisa paham ya. Ini sudah saya ajarkan bagaimana menghitung di luar ada solenoid panjang, di dalamnya ada solenoid kecil yang sudah itu. Yang silakan dihitung ulang ya. Tapi yang untuk ini enggak ya. Ini kan ada, oh iya, yang ada film magnetik ini enggak ikut biasanya, enggak ada. Ini ada sini-sininya, ini biasanya enggak ikut. Nah, tadi itu ada ya. Lagi-lagi yang sudah pernah saya tunjukkan ya. Di luar ada solenoid panjang, di dalamnya ada solenoid. Please, if you have the question, I will wait in 1 minute. Any question, everyone? Tomorrow you will have assistant at 9 a.m. Yeah, with Mas Isar, ya, Mas Iwan. And we will meet again in final exam and the second week of final exam. And please open your video test. Open your video so I can supervise when you write your work video. And hopefully I will accomplish my duty to create your assignment, and I will share the result very soon. But I haven't finished yet. Yeah? Hopefully I can accomplish as soon as possible. Any question, everyone?
I think it's clear, sir.
Okay.
I think yes, sir.
Okay, please write again the example that I have given in the classroom. Okay, thank you very much for coming, everyone. See you in final exam. Hopefully you can pass this course, yeah, successfully. Okay, thank you very much for coming. Evening. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.
Welcome.